All right, how's it going, everyone? All right, so what we're going to do today is we're going to be talking about the product chain rule, okay? Now remember, the product rule is if we have f times g, I'm going to take the derivative, it's going to be the first term intact. Oops, what am I doing? It's the first term intact times the derivative of the second, derivative of the second component plus derivative of the first component, second component intact. So same thing's going to apply here. We're going to pretend like this is going to be times this, but we also have to apply the chain rule because it's an expression raised to an exponential power. So here's how this works. So the derivative would be first component intact. So I'm just going to put 3x minus 1 squared, just like that, like it normally is. Now the derivative of this one is going to be 3. You have to apply the chain rule. 2x plus 4. Subtract 1 from the exponent. So it'll be squared times the derivative of what's inside, which would be 2. Now plus the derivative of the first component. These are two components. And that'd be 2 times 3x minus 1. Subtract 1 from the exponent, get the first power, times the derivative of what's inside of this, which would be 3, times second component intact. I'm going to clean this up. So I end up with 6 3x minus 1 squared times 2x plus 4 squared plus 6 times 3x minus 1 to the first power times 2x plus 4 cubed. Now, this is kind of a mess. If I was trying to determine where the function had a horizontal tangent line where it equals 0, this would be a horrible mess to try to solve this. So I'm going to show you an easier way to solve this. What we're going to do is we're going to take out the greatest common factor out of this term and this term. So they both have a 6. We put 3x minus 1 to the smallest exponential power that is present. So there's a 2 and a 1, so it's going to be to the first power. And then 2x plus 4, the smallest exponential power that is present, is going to be the 2, so squared. Now what I'm going to do, I'm going to put this greatest common factor out front. And now I'm going to divide each term by this greatest common factor. So when I divide this first one by this greatest common factor, the 6's cancel out, the 2x's plus 4 squared cancel out. All I'm left with is a 3x minus 1 to the first power. Because you subtract them. 2 minus 1 would be, if you're dividing, 2 minus 1 gives you 1. Plus, this comes down, the plus comes down. Divide, now I divide this one by a greatest common factor. The 6's cancel out, the 3x minus 1's cancel out. Now 2x plus 4 cubed over 2x plus 4 squared leaves me with 2x plus 4. And now I can simplify this. So I get 6 times 3x minus 1, 2x plus 4 squared, and I have 5x plus 3. That is the derivative. And that would be way easier to determine where it has a 0 for has a horizontal tangent line, where it has 0 for the slope. Simply set each of these factors equal to 0. That's why we get it in this form as opposed to this ugly, hideous form here. Okay? Let's look at another one. All right. So this one, I'm going to leave the first component intact, which is that, that 2 is going to go along with this. That'll be part of the first component. Times the derivative of the second one, which would be apply the chain rule, 6 times x squared plus 2. Subtract 1 from the exponent to get a 5. Times the derivative of what's inside of here, which would be 2x, plus derivative of the first one. Now this is to the first power, so all you do is just take the derivative of what's inside. It's going to be 2 times the derivative of what's inside here, which would be 2x, times the second component intact. Now I'm going to clean this up. Whoops. Let me clean this up a little bit. Okay, so we get 24x, x squared plus 1 times x squared plus 2 to the 5th, plus 4x, x squared plus 2 to the 6th. So the greatest common factor is going to be 24x and 4x would be 4x. There is no x squared plus 1, so I don't include that. And I just have x squared plus 2 to the 5th power, smallest exponential power that's present. I put my greatest common factor out front. I'm going to divide each of these components by my greatest common factor. So let's divide this first one by this. 24x over 4x gives me 6. X squared plus 1 is going to be in there because it's not present here. X squared plus 2 to the 5th. Those both cancel out, so I'm just left with this. Plus 4x over 4x cancels out. X squared plus 2 to the 6th over x squared plus 2 to the 5th leaves me with an x squared plus 2. Let's simplify this out. It gives me 6x squared plus 6 plus x squared plus 2. And so my derivative is going to be 4x times x squared plus 2 to the 5th, 7x squared plus 8. Ta-da! Nice. Okay. And let's do one more example. Okay. All right, I'm going to rewrite this as x plus 2 cubed times x minus 1 to the negative second. Because that's in the denominator, I'm going to move it up to the other side of the fraction bar and change that exponent to a negative. Now I'm going to apply the product chain. First component intact. Take the derivative of the second component, so I get a negative 2. X minus 1, subtract 1 to get negative 3. Times the derivative of what's inside, which is just be 1, plus the derivative of the first one, 3 times x plus 2 squared, times the derivative of what's inside, which is 1, times the second component intact. Let's clean this up. This is the times, by the way. So we get negative 2, x plus 2 cubed, x minus 1 to the negative third, plus 3, x plus 2 squared, x minus 1 to the negative second. All right, so my greatest common factor, so I can't do anything with the negative 2 and the 3. So my greatest common factor is going to be x plus 2 to the smallest exponential power present, which would be 2. And then x minus 1, the smallest out of negative 3 and negative 2 is going to be negative 3. So I'm going to put those out front. Now I'm going to take each of these components and divide it by my greatest common factor. So there's no negative 2, so that goes right here. X plus 2 cubed over x plus 2 squared leaves me with an x plus 2. X minus 1 to the negative third over x minus 1 to the negative third cancel out. Plus 3 over nothing give me 3. Or 3 over 1 basically would be a 3. X plus 2 squared over x plus 2 squared cancel each other out. Now x minus 1 to the negative second over x minus 1 to the negative third. What happens is when you're dividing, which is what we're doing, dividing each of these components by our greatest common factor, you subtract the exponents. Remember, if you have x to the 7th over x to the 5th, you just go x to the 7th minus 5, which would be x squared. So we're going to subtract these exponents. So negative 2 minus negative 3 becomes negative 2 plus 3, which becomes 1. So x to the first, x minus 1 to the negative second over x minus 1 to the negative third leaves me with x minus 1 to the first power. So there you go. So we're going to clean this up. I get negative 2x minus 4 plus 3x minus 3. And so my derivative is x plus 2 squared, x minus 1 to the negative third, times x minus 7. But we want to rewrite this. I'm going to write it up here at the top. I'm going to erase this real quick, y'all. We don't want a negative exponent because we are couth. So we're going to rewrite it as such. X plus 2 squared times x minus 7 over x minus 1 cubed. And there you go. Hopefully this all makes sense. Just try what you can on the worksheet. We're going to be going over this tomorrow as well, but I just want to give you all a little head start. And talk to y'all later.